Hey everyone, hopefully now we understand isotopes, isotope notation, and now we're going to take a look at average atomic mass. Um, so when we calculate the mass number of an isotope, it always comes out to be a nice whole number. So that brings up the question, when we get to our periodic table, why do we have these values with so many decimal places and they don't actually turn out to be whole numbers? That's because the periodic table gives us the average atomic mass, which is a weighted average based on the isotopes that we see in nature and their percent abundance. So if we look here, we have a nice equation to help us figure out the average atomic mass. What we're going to do is we're going to take the mass of an isotope and we are going to multiply by the percent abundance, and then we're going to add all of those different isotopes times their percent abundance together, divide the whole thing by 100, and that will give us our final answer. So if we look here, I am looking at oxygen in our first example, and our oxygen has, see this new technology, it's messing me up. Our oxygen has three different isotopes. So we have oxygen 16, oxygen 17, and oxygen 18. And then we've been given the percent abundance of each of these. Oxygen 16 is by far the most common. So oxygen 16 has a percent abundance of 99.76%. Oxygen 17 has an abundance of 0.04%. And then oxygen 18 has a percent abundance of 0.20%. So what we want to do with our oxygen here is take the mass number, which in this case we would start off with 16 for the mass of oxygen 16, multiplied by our 99.76%. And then we are going to do the same thing for all of our other isotopes. So oxygen 17, and then multiply by its percent abundance, which is 0.04. And then oxygen 18, which has a percent abundance of 0.20. We are going to plug all of that into our calculator, add them all together. So as a reminder, we could put parentheses around that. And then we are going to divide this whole thing by 100. Notice that I plugged my percentages in as they are written. So when I do 16 times 99.76 plus 17 times 0.04 plus 18 times 0.20, I'm going to get that whole thing. And then I'm going to divide that entire thing by 100, and then I would get the average atomic mass of 16.0044, which we are going to round to 16.00. And our unit here, our atomic mass units when we are finding our average atomic mass. So that's going to be my final answer here. We can look at another example. So I want you guys to go ahead and pause the video and see if you can work through this example. So find chlorine's average atomic mass if approximately 8 out of every 10 atoms are chlorine-35 and 2 are chlorine-37. Go ahead and pause the video real quick, see if you can get this one started and solve it. And then after you've tried it, we can go back through it together. So I'll give you a second to pause. Okay, if you're back with us, hopefully you've given this one a shot on your own. But let's look at this example together. So I've got two different isotopes of chlorine. I've got chlorine-35 and chlorine-37. Chlorine-35, it tells us that 8 out of every 10 atoms are chlorine-35. Cool, but I need to know what percent of my atoms are chlorine-35. So off the top of your head, because these numbers work out pretty easily, we can probably tell that that's 80% of our atoms. If we had a more complicated example, if we didn't have 10 total atoms, but we had a different number, we could find the percentage just like we've always done before. We can take the part that we're interested in, which is 8, divided by the total, which in this case would be 10, multiply that whole thing by 100%. We can do the same thing for chlorine 37. So chlorine 37 is 20% of our natural abundance. If you weren't sure where to start, this is going to be our first step. Now that you've seen me set up this first step, again, I'm going to ask you to pause the video and see if you can solve the rest of the question. If you've already solved the question and you just want to wait and see if your answer is correct, you can hang tight for just a second. All right, now everyone should have gotten to a final answer, and we can go back and check. I've got two different isotopes. One has a mass of 35 atomic mass units. We're going to multiply that one by 80% because that is its percent abundance. Then we're going to add our second isotope, which has a mass of 37 atomic mass units. We're going to multiply that by 20%. And then I'm going to plug this whole thing into my calculator. And then after I've hit enter, I can divide by 100, and that'll give me my final answer. So I can take 35 times 80 plus 37 times 20, hit enter, divide that whole thing by 100, and we'll see that our average atomic mass for chlorine is 35.4 atomic mass units. A good way to check yourself on these problems is to check your periodic table. If we find chlorine, we'll see that our table has it listed as 35.45. So our calculation here is pretty darn close. Couple things to keep in mind. When you're doing these types of calculations on an assessment, you will have to show us your work. Because obviously you have the periodic table on the assessment. We're not just asking if you can find the average atomic mass on the periodic table. If we're asking you to calculate the average atomic mass, you'll have to show us this calculation. So if you just write down a final answer without any work, we won't be able to give you credit because we can't tell if you knew how to set the problem up versus if you just looked at the periodic table. These calculations are important because every once in a while, we might give you the data for isotopes of different elements, but not tell you what element it is. So I might have just told you that there was an isotope that had a mass of 35, an isotope that had a mass of 37, given you their percent abundances, and then asked you to figure out what element it is. And that's something that chemists will have to do in lab every once in a while. It can help them identify different elements based on the average atomic masses on the periodic table. This whole little mini rant is just to say, make sure we know how to do these calculations. Even though the answers are all given to us on the periodic table, on an assessment, you're going to have to show us this work. We might round to a different number of sig figs compared to what the periodic table gives you. So just spend a little bit of time practicing these. They're not super difficult. Just remember, it is a weighted average. It is not a normal average. Hope you're having a day, and we look forward to seeing you next in-person class. If you have questions, feel free to reach out to your chemistry teacher. Thanks, y'all. Bye.